Bismillahirrahmanirrahim. Welcome back to my channel. Today we're going to look at Mini Circuit 3dB Attenuator 15542. It's actually a 3dB attenuator right here. I have connected this via to my VNA using an SMA female, both sides, to one end of a attenuator and the other side to via my VNA cable. This is how I connected this, if you can clearly see. So let's look at the response of this. This is a 3dB attenuator and it's a two-port device. So we're going to look at two-port S11, S12, S21, and S22. So let's quickly look at this using my VNA. Alright. So the first thing I want to look at using my VNA is actually going to be my S11. So once I look at my S11, this is the response that I should get. As you can clearly see, this is return loss, and that is going from negative 10 dB, from 0 dB all the way up to negative 90 dB here. And so this is how the response should look like for a two-port device. That has a perfect match throughout the spectrum from 100 kilohertz all the way up to about here, up till, you can even say about here, up till marker 6, 7.7 gigahertz, and up till marker 7 it's going a little bit negative 8 dB. So this is the graph. This is what I should expect. This is how an S11 should look like. S11 and S22, it should be the same. So let's look at S22. And indeed it's almost exactly the same. So this is what I would see, that the response should be below negative 10 dB, because S11 is the reflection from input port to an input port, port 1 to port 1. And S22 should be a reflection from port 2 to port 2. So they are symmetric because they are diagonally. When you're designing attenuators, it should be symmetric. Now let's look at the graph. Since it's a two-port device, now let's look at the graph that I'm interested in seeing, S12. S12, what means is actually from port 2 to 1. So from port 2, so this side, which is on my right hand side, this is port 2 and this is port 1. So let's look at it. This is my port 1, this is my port 2. So S12 is actually telling me how much is reflection coming from port 2 to 1. So let's quickly look at this. This is what I'm seeing. Attenuator. So this is S12. Now let's look at S21. Why I want to look at S21 first? Because from port 1 to port 2. S21, the way you read it is from port 1. So this 1 is actually from, and this 2 is 2. So from port 1 to port 2, how much reflection I would see? How much gain would I see? Since it's an attenuator and it's rated for 3 dB, I should see the 0 dB graph should be going to about negative 3 dB, and indeed it is going to negative 3. So if you were to look at marker 1 at about 3.23 gigahertz, I was getting negative 4 dB. Yes, there were some calibration issues. There might be a difference of negative 1 dB, but keeping that in mind, it's almost negative 4. Now at 4 gigahertz, it's negative 4. So this attenuation is quite constant, right? So it is giving you, it's supposed to give you negative 3 dB, but it's giving you a little bit more than negative 3 dB. That is perfectly fine when you're using an attenuator. That is perfectly fine because I might have calibration issues associated with my VNA and stuff like that, but that's perfectly fine. And this is exactly the graph I should observe from port 1, from port 1 to 2. From port 1 to 2, and then from port 2 to 1, I should see exactly the same thing because they are symmetric. They are diagonally symmetric. When you're designing attenuator, you want to make sure S11 is exactly as S22, S12 is exactly as S21, because you can connect this attenuator in whichever position you want. You can either connect it from port 1, where I have connected my port 2, I can connect that to port 1, and then from port 2, I can connect port 2 to port 1. It doesn't matter. The response should be exactly the same. These are the things that you need to look out for when you're using attenuators. Since it's a two-port device, you should be looking at S12, S21, and S22s and S11s. The other thing that is important for amplifiers, the thing that we are interested in also, if it were an amplifier, the way we're going to test it, we're going to actually look at the gain of it. We're going to look at the gain. The way we're going to look at the gain from port 1 to 2, how much gain is given. So instead of 0 dB, I should see a value in positive numbers. Since it's an attenuator, I would see the value in negative. If it was an amplifier, I should be seeing the value in positive numbers. That tells me how much amplification is being done. I can also check amplifiers using the spectrum analyzer as well. So if you have any questions, leave it in the comment section. Don't forget to like and subscribe to my channel.